Number 15, antibiotic resistance can vary within a population of bacteria. The diagram below represents the changes in a population of bacteria as a result of exposure to an antibiotic over time. Okay, and so we have our original population and a final population, and this key is going to be important in just a minute. The changes in the population are most likely the result of which of the following? So changes, most likely the result. All right, so let's go look at some of these keywords and phrases that we highlighted. Okay, so antibiotic resistance, that is when medicine doesn't work. Okay, so some bacteria have a gene basically that allows them to be antibiotic resistant or not be killed with medicine that we have. Okay, remember antibiotics, they work on living things like bacteria. Okay, so some bacteria already have an adaptation, they have a trait that allows them to be resistant to our medication. Okay, and what we're going to see is over time a change in the bacteria population. Okay, and the question is asking us why. Why are those changes going to take place? So let's look at our image and see what we have. Okay, let's look at our key first. So we see that a white circle or a light gray is going to mean that there's a low antibiotic resistance level. So that means that the antibiotic works on them. Okay, so the bacteria, if there's a low antibiotic resistance, they're going to be killed. But the darker gray and the black circles are going to be bacteria with a high antibiotic resistant level. That means that they are not impacted, so they are not going to be killed by our medications, by our antibiotics. So when we look at our original population, we can see that most of the population is on the low antibiotic resistant level. So most of them are going to be killed. All of the light grays and the whites, okay, they're all going to die. So all that's left are a couple bacteria that have high antibiotic resistance that aren't killed. So because these are able to survive, these bacteria will reproduce, okay, through asexual reproduction. And they're going to basically make clones of themselves. And so we see in our final population, the only thing that's left are antibiotics, high antibiotic resistant level bacteria, okay, a bunch of bacteria that are not killed by the antibiotics. Okay, so this process that we're seeing right here is survival of the fittest. Okay, the ones that are surviving are the ones that are fit, that have the best trait, the best adaptation. So looking down at our answer choices, A, exponential growth. Okay, we're not seeing the population grow in numbers. Okay, that's not what we saw. B, genetic crosses. Okay, we haven't done any Punnett squares. C, immigration. Okay, it never talked about any bacteria moving in. Okay, that's what immigration is. So we didn't see that. Or D, natural selection. Remember that natural selection is survival of the fittest. So that is a perfect example of natural selection that we see in this question. So D is the correct answer.